Okay, so today you are taking notes in your notebook over the structure of our solar system. So here we go. All right, so first you need to understand for unit of measure, we use a unit called the astronomical unit for our solar system. It equals the average distance from the Earth to the Sun. So 1 AU is how far away the Earth is from the Sun. So that's kind of your standard set. 1 AU is that distance, which happens to be 93 million miles. That's how far away from the Sun we are on average. And then any other planets would be, have an AU as well. So like, for example, Venus is closer to the Sun than we are, so it would have less than 1 AU, whereas Saturn would have much more than 1 AU. So starting tomorrow, we're going to get going on a project that you will get to choose a planet or a moon to learn about. And if you have a planet, you'll need to know the AU. So you'll look that up, and now you understand where it comes from. Okay, the planets. So in order to be considered a planet, it has to have 3 criteria. It has to be spherical, has to orbit the Sun, and it has to have cleared its orbital path, which is, in the beginning we talked about when we collided with Theia, there were a lot of loose space rock still floating around, so we would have collisions all the time. We've cleared our path. Yes, there might be some asteroids that come towards us, but they're not in our orbit. It just may cross paths. But there's no danger of us colliding with anything along our journey here around the Sun. So there's 2 groups of planets. They have their kind of own planet family. The first 4 planets are called the terrestrials. They are all small and rocky. So that would be Mercury, Venus, Earth, and Mars. So the 4 of these have way more in common than they do with the other ones. And then the last 4, the other family, are the gas giants, which would mean that they are all very large in size, even though the pictures here do not match up. They are made of gases, so they're gaseous, and they all have rings. Yes, they all do. I know Saturn is the one with the noticeable rings, but all 4 of them do have rings. And a large question, or common question that I get asked sometimes is, if they're made of gas, would you just fall through it? No, the gas will kind of act as a solid because it's compacted so much together by its immense gravitational pull. And also, there is strong evidence to suggest that the gas giants all have solid cores. So the gas giants would be Jupiter, Saturn, Uranus, and Neptune. Next up are the asteroids. So we have 2 belt systems of where the majority of the asteroids exist. So they're kind of loosely around, scattered in this orbit. And they, however, can have the ability to bump into one another. So if they bump into each other, one could get ejected out of its orbit, in which case it could come, especially if it's going inward towards where the Sun is, it could cross our path. So we track all that. NASA knows exactly what is coming near to Earth as far as asteroids. So they are small rocky bodies that orbit around the Sun. They would not be considered moons or planets. They are not spherical. They definitely have not cleared their path, obviously. So these would not ever be considered a moon or a planet. There's 2 belts that you need to know. The asteroid belt is the main one, and it exists between Mars and Jupiter. And the next one is called the Kuiper Belt, and it's located just beyond Neptune, which is where Pluto is located in. Okay, next. Dwarf planets. Speaking of Pluto. Okay. So, a dwarf planet is kind of a relatively newer family that was categorized due to Pluto being kicked out of the solar system. So, when they decided Pluto should no longer be considered one of the main planets, the reason being is that technically it's in the Kuiper Belt, which makes it not have cleared its path. Pluto could still cross paths with other objects and collide. So these are considered dwarf planets. There are many dwarf planets. Pluto is not alone in its family. The two that I'm going to have you know and memorize, there's the most famous dwarf planet in the asteroid belt is called Ceres. And in the beginning, Ceres was originally thought to be a planet until Galileo saw it with the telescope and realized, nope, not one. And then Pluto, which is in the Kuiper Belt. Okay, next. Satellites. So satellites is the sciencey word for moons. So natural satellites are moons. So anything that is naturally, so not an artificial satellite that like NASA built and put out into space. Natural satellites are the things that orbit around planets. Ours is obviously named, yes, we call it our moon, but honestly, its real name is Luna. But we always just call it and refer to it as our moon. Not all planets have satellites. Like Mercury, Venus, they don't have any. And Jupiter and Saturn have a ton. Way more than what you see here. These, by the way, the ones that you see here for Jupiter, those are the Galilean moons. Io, Europa, Ganymede, and Callisto. All right, so last up, we're going to talk about how the solar system formed, and it's going to be in a similar way that we talked about the moon forming. So 4.6 billion years ago, once our star, our sun, began its life, and that's our next unit, so you'll understand that later, just when it became a star, the immense gravitational pull of it brought like large, vast amounts of gases and larger particles to it. And because, just like orbital motion, right, because of gravity and inertia, it formed these orbiting motions of all this stuff circling around the sun. And they would coalesce and accumulate through accretion and build up larger objects as it went, destroying some and then consuming and kind of taking it in and making them larger. So the heavier elements from the past stars would get pulled towards our newly formed sun. So when stars die out, they scatter a bunch of their remnants elsewhere, and then that gets pulled together to make into planets and then other future stars and such. So the rotating disk of heavy elements that clumps together, the larger objects that it forms through that accretion process that I told you, those are called planetesimals, which are basically like the early versions of planets, so like baby planets. Not all of them would go on to make full planets that we have today, but they were larger in size. So the heaviest material would get pulled to the center, again, because it's heavier, so it has more effect from the gravitational pull of the sun. So they all went toward that, and those would make rocky planets. So materials like nickel and aluminum and iron, those heavier things would go towards closer to the sun and would get made into those rocky planets that we exist on. And then the lighter material, the more lighter gases, would stay farther away and clump together and form those gas giants. Okay, very last, you do need this in your notes, so you'll need to draw this in your notebooks. It contains not only the order of the planets, but it also shows their groupings of the terrestrial versus the gas. It's added in the asteroid and the Kuiper belts with our dwarf giants, with our dwarf planets. And then it's shown you the AU. So one way to remember the order of the planets, this is just an example. It's a mnemonic, which means the first letter of each word represents what you're trying to remember. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. My very eager mother just served us nachos. Of course, when I was your age, Pluto was still a planet. So we learned it. My very eager mother just served us 9 pizzas. But we've switched to nachos, guys. So add that in, and then you are done. Have a good day.